For this video, we're going to show you how you can clean and transform the ECG signal due to any potential artifacts. Now, these artifacts could be movement related, they could be breathing related, or anything that's just jostling the signal in one way or another. Sometimes it could be that the electrodes weren't attached, securely, or any other variety of reasons, or it could be due to just individual differences in kind of heart rhythm for certain folks. Like, so from some of our older adults, there's certain arrhythmias that can pop up, or there can be a drop off in signal that we have to basically extrapolate where an R peak should be located in those types of instances. All right, so this is actually a signal that we deliberately tried to create some artifacts in. Now, what you'll see to start with, this is the beginning of a baseline condition for a particular participant. All right, you'll notice at the start here, I've deselected all the channels with the exception of the ECG channel. And at first glance, these first few R peaks look pretty clean. They look pretty, solid. They look pretty, not too. This would be the type of signal that we would actually want. But as we scroll down a little bit, you're starting to see that there's a little bit of, erratic patterns in the ECG complex. Now, even though you see that some of these patterns in between the R peaks look a little oscillating, as long as these R peaks are still present and accounted for, you don't have to really worry about the nature of this signal. So for instance, if I zoom in here, you see that there's this little kind of drop off in signal right here. Well, that's not going to be a problem because typically we don't care about that portion of the wave when we're doing our RSA analyses. We only care about these R peaks right here. Okay, so this little drop off in signal isn't going to be a problem unless this drop off extended all the way through to where we would expect this peak to be, and then this peak is no longer present. Okay, in those instances we would have to do some extrapolation. All right, so let's continue on here. And again, these peaks look pretty solid. Okay, so now you can see things are getting a little hairy. All right, so if I zoom out for just a second, you'll notice, all right, so we have a very large kind of mess of waves here. Now, at first glance, this looks pretty ominous and difficult to reconcile, but you'd be surprised, there's actually ways for us to go through here and identify what truly are the R peaks that we should see within this sample. Okay, even though there's several that look like they could be candidates, there are specific aspects of the R wave that we are really going to be able to identify. And there's two components that we're going to be mindful of when we're trying to select out where the true R peak is. One is going to be the shape of the wave. Okay, and we can usually use the clean R waves like we see over here as a comparison, and then also the distance between the R peaks. Okay, so using those two metrics, we can more or less reliably identify where our true R peak should be located. Okay, so I'm not going to show you how we would clean this entire set, but I'm just going to give you a little bit of a rundown of how we would at least fix a couple of these waves. And once you've figured out how to identify which ones are the true waves, you'll start to get the hang of it after you've looked through these several times. All right, so what I want to do is I want to start by just kind of zooming in within this little range right here. Okay, all right. So what I'm going to be doing here is I'm going to try and find within this little range where I think my R peaks should be located. Okay, the first thing I'm going to do is I'm going to look again at the shape of the wave. So this is the shape of my R peaks. Okay, so there's a little bit of a, flaring out, towards the middle point of the wave, and it kind of comes up to a little bit of a peak. All right, so if I'm looking at the shape, there's a few of these shapes that I can probably already right off the bat say that these are probably not going to be the same shape as these two R peaks. For instance, this one right here. The top looks to be a little bit too broad and wide. Okay, This one, about the same. This one might also be a little bit too broad and wide, but maybe this one right here maybe fits the bill a little bit, okay? And then maybe this one right here, or, you know, one of these three, okay? Now, in order to make this determination officially, I need to look at the distance between peaks. So I'll look at the distance between the two most recent clean peaks, put my I-beam tool here, and then look at the distance. So look at that interbeat interval between these two. Okay. And I'll look up here and it says about 0.724 seconds. All right, so that's what I'm using as kind of my benchmark. I can even go back a little bit further and look at the distance between these two peaks. And it's about 0.738, roughly the same distance between 0.72 and 0.74. Now what I want to do is I want to find this clean peak, and now I want to go all the way to the right until I hit roughly 0.72 to 0.74 seconds. Okay. All right, and lo and behold, we're at about 0.69 there. But as you can see, if I go too far, if I go to this peak, we're at 0.78. We're already a little bit too far. And if I go here, not far enough. This seems to be, in terms of the shape of the peak, the most reliable in terms of the distance, as well as the shape of the peak in terms of similarity with this R, and then also the distance is about the closest approximation. Okay, so what I want to do is I want to make sure that this is going to be my peak that is identified. So what that usually entails is dropping down certain peaks that are too tall, like this one for instance, and this one, and then maybe boosting this peak up just a little bit. Okay, so what I'm going to do is I'm going to put my I-beam somewhere in the middle of this wave and then highlight it to encompass the other half on the other side. And the way that we move peaks here is we go what's referred to as a transformation procedure. So you go to the transform at the top here, and you do what's referred to as waveform math. So that basically is a mathematical adjustment to the actual waveform. So click on that. Okay, so it's asking me what source I want, channel 13, this is what I have. And then what mathematical operation that we can do. We can do add, subtract, multiply, divide, or do exponents. And then a source, which is just basically a constant, okay, and to put it on this wave. All right, so the K you're not going to change. K is just a constant, and we usually do a little bit of trial and error in terms of what we should have in our K constant, depending on whether or not you're adding, subtracting, multiplying, or dividing. Typically, we're going to use the division for bringing down the waveform, and so I'm going to show you two examples of that here. So I'm going to start just with the number 2 as my K and see how far down that drops this waveform. Click OK. Okay, and it did a pretty good job of dropping that down. All right. Now what I want to do is a similar thing with this very tall wave here, which I think Acknowledge would want to identify as an erroneous peak. So I'm going to highlight that one again. Transform. Now I can go to recently used, waveform math, and then do the same thing. Now this peak was a little bit taller than this one, so I might even try like 3.5. Click OK. Okay, so now you see that that wave drops down considerably. Now, the fact that it's kind of like looks a little goofy with these little peaks here, you don't really have to worry about that. As long as these peaks are the more prominent ones, these are peaks, the system is going to be able to identify it a little bit better. I might zoom in just a little bit to make sure that I'm really getting the bulk of this waveform right here. Okay? So what I'm going to do is I'm going to transform. Now I want to move this peak up a little bit. Okay, so I'm going to actually do the addition sign for this, and I'm going to go pretty small, all right, because adding actually jumps up quite considerably here. And if I do like a point, maybe a 0.5. Okay, and I'm going to zoom back just to see how high up that looks. Okay. And that looks pretty good, okay? All right, so now what I want to do is I want to see now, all right, is this going to be identified as a QRS peak in Acknowledge. Okay, so I'm going to go now to Analysis, Locate Human ECG Complex Boundaries. And it appears that that's the case. All right, so the QRS here, perfect. That's what I want to see. Okay, now the question becomes, well, is that an actual QRS right here? Should that be our QRS? What about here, or even maybe down here? Okay, so for the next one, what I'm going to do, first and foremost, I need to get rid of these waveforms. So I'm just going to go click on Edit, and I'm going to clear all. Okay, and again, I need to look at the distance and the shape. Okay, so my distance again is around 0.72, 0.7, 0.74, somewhere in that range. So I'm going to highlight, just scroll over. What do we have here? We're looking at about 0.41, not far enough. We look over here, 0.53, not quite. 0.58, not quite. And 0.64 looks like it's maybe going to be the closest that we're going to have in terms of waves that are reasonable. Okay, so even like this one right here, even if I looked at this wave all the way over here, this little tiny little notch, we're way beyond the 0.72. Okay, so even if it's not quite exactly 7.2, 7.3, 7.4, this is about a reasonable distance. Okay, so I would suggest that this is probably going to be our identified QRS peak, and it actually was. This happened to be one that Acknowledge, determined was one of our QRS complexes. But if I was a little leery about Acknowledge identifying it and being confused with these ones right here, I would just go through ahead and just select this whole segment here and just bring it down. So go to Transform, Waveform Math, go back to Divide, and I might divide by, let's say 3 this time. Okay. Right, and so that brings that down considerably. All right, and so now I'm going to go back, locate my ECG complex boundaries, and notice that my QRSs are now where they should be. Okay, so that's how you do kind of basic transformation and cleaning. All right, now there's ways that we can also do inclusions for dropped signals, and for another video I will show you the ways that we kind of deal with that issue as well. But you would do all of your cleaning. Okay, so after you've added those in, you would subsequently go through here and then move these waves around to see, okay, which of these should be my R peak since they're not being identified. And if there's a little bit of confusion with relation to some of these other ones here, we would still have to clean out this signal before we get back over here. Okay. But that gives you a basic idea of how we go through and clean through our signal.